Hello and welcome to Maths with Mr Amison. Today I'm going to be talking to you about trapeziums. The first question I want to ask is written down here. Is this true or not? Have a think about it. So parallel lines never cross another line. While it's true that parallel lines never cross each other, they can cross another line that is not one of those parallel lines. And for the second question, a quadrilateral must have exactly 4 sides, not at least 4 sides. So let's talk about what trapeziums are and what they're not. Have a look at these 7 shapes and decide whether or not you think they are trapeziums. Now, to give you a definition for those of you who aren't sure, a trapezium has exactly one pair of parallel lines. I'm not going to be talking today about how rectangles and whatever are types of trapezium. I'm not going to talk about that. I'm just going to define the standard trapeziums. So number 1, the top line and the bottom line are parallel. They go in exactly the same direction and they never meet each other. Therefore, shape number 1 is a trapezium. Shape number 2 has the top line and the bottom line parallel, but also the left and right are parallel. Therefore, it is not a trapezium. And because these lines are the same length, this is in fact a rhombus. Shape number 3, similar to shape number 1, the top and bottom line are parallel, and the sides are not. Shape number 4, the left and right are parallel, the bottom and top are not, therefore number 4 is a trapezium. And bear in mind, all of these have 4 sides. Trapeziums are quadrilaterals. Therefore, number 5, while it has one pair of parallel lines, it has 5 sides. Therefore, is not a trapezium. Number 6 looks a bit different. However, number 6 is also a trapezium because even though these lines are both tilting to the right, the top and bottom line are parallel. Therefore, it's a trapezium. Number 7 is similar to number 2, it's just rotated. The line here and here are parallel, the line here and here are also parallel, therefore this is a rhombus. If these lines were a different length to these ones, it would be a parallelogram. Okay. So I want to go through, see if we can move one vertex and make these shapes. Have a think about how you might do that. Now, a vertex, for your information, is the corner of a shape, if you'd forgotten that. So to have a go at making the kite by moving one vertex, we can move this corner. So extend it to make it quite kind of like that, and we can move it to there. Now, a kite, by definition, has 2 lines that are the same length, going from a single point, and then from its opposite point 2 lines that are the same length as well. If it has that, and specifically this angle here has to be less than 180 degrees. Both of these angles have to be less than 180 degrees. If this point moved over here, it would become a straight line, or here it would become more than 180 degrees and therefore an arrowhead. So there were only 2 answers to that. You can do that with any corner. For a trapezium, there's a lot of different ways we could do this. We could move the point to here. We've still got the top and bottom line parallel. We could move it along. We can continue to do that. And we've still got a trapezium because we have the top and bottom line parallel, and we can extend it as well. We've got the same thing. We don't have to have the top and bottom line. We can have the left hand and the right hand side parallel, and we don't have to just move that point. We can move any other point and we get a similar story, as long as we have 2 sides of the parallel. Now, it's worth noting that you can't actually make a parallelogram or a rhombus by moving one vertex. You'd actually have to move 2 vertices to be able to do that. So there's no answer to that one. So to finish off, I want to leave you with these questions to have a think about. Thanks for watching, and see you soon.